The Mil V-12, given the project number Izdeliye 65, is the largest helicopter ever built. The designation Mi-12 would have been the name for the production helicopter, and was not applied to the V-12 prototypes. Design and development, design studies for a giant helicopter were started at the Mil OKB in 1959, receiving official sanction in 1961 by the GK-80 instructing Mil to develop a helicopter capable of lifting 20 to 25 t. The GK-80 directive was followed by a more detailed specification for the V-12 with hold dimensions similar to the Antonov An-22, intended to lift major items of combat materiel as well as 8K-67, 8K-75 and 8K-82 intercontinental ballistic missiles. Design limitations forced Mil to adopt a twin-rotor system, but design studies of a tandem layout, similar to the Boeing CH-47 Chinook, revealed major problems. The single-rotor layouts also studied proved to be non-viable, leading to the transverse layout chosen for the finished article. The transverse rotor system of the V-12, which eliminates the need for a tail rotor, consists of two Mi-6 transmission systems complete with rotors mounted at the tips of the approximately 30 m span inverse tapered wings. Although the first use by Mil, the transverse system had been used by several of the early helicopters, including the Focke-Wulf FW-61, Fock-Achilles FA-223 Drac and Kamov Ka-22 Vintokral convertiplane. Construction of the V-12 first prototype, after exhaustive testing with test rigs and mock-ups including a complete transmission system, began at Pankey in 1965. The airframe was largely conventional, using stressed skin construction methods with high-strength parts machined from solid. The large fuselage accommodated the 28.15A, 4.4A, 4.4M cabin and crew section in the extreme nose, housing pilot, co-pilot, flight engineer and electrical engineer in the lower cockpit, with the navigator and radio operator in the upper cockpit. At the aft end of the fuselage, access to the cabin is gained by large clamshell doors and drop-down cargo ramp with inbuilt retractable support jacks. Doors in the fuselage also give access to the cargo hold, 2 on the starboard side and 3 on the port side. Above the rear fuselage is a very large fin and rudder, with a moderately sized tail plane with dihedral fitted with end plate fins. The fixed undercarriage consists of large paired main wheel units on pneumatic levered shock absorbers mounted at the junction of a strut system supporting the rotor systems and wings and connected to the center fuselage by a tripod strut structure with the nose leg attached aft of the crew section. A pair of bumper wheels are mounted at the rear of the fuselage keel and fixed support pads ensure that the cargo ramp is extended to the correct angle. Long braced struts also connected the transmission units to the rear fuselage forward of the fin. Cargo handling is by forklift or electric hoists on traveling beams. The power system and wings are mounted above the center fuselage with interconnecting shafts ensuring synchronization of the main rotors which overlapped by about 3 m. Drag and lift losses are reduced by the inverse taper wings with minimum cordon regions of strongest downwash. The interconnecting shafts also ensured symmetrical lift distribution in event of engine failure. To optimize control and roll and yaw, the rotors are arranged to turn in opposite directions with the port rotor turning anti-clockwise and the starboard rotor turning clockwise, ensuring that the advancing blades pass over the fuselage. Each power unit comprises 2 Soloviev D25EF turboshaft engines mounted below main gearboxes which each drive 5-bladed 35 m diameter rotors and the synchronization shafts which run from wingtip to wingtip. Each paired engine pod has large access panels which open up for maintenance access and also form platforms for servicing crews to operate from. Control of the V-12 presented several problems to the designers and engineers due to the sheer size as well as the rotor layout. The pilot and co-pilot sat in the lower flight deck with a wide expanse of windows to give excellent visibility. Using conventional cyclic stick, collective lever and rudder pedals, the pilots input their commands in a conventional fashion. Roll control is by differential collective pitch change on the left and right rotors, ensuring that sufficient lift is generated to prevent inadvertent sink. Yaw in the hover or lower speeds is achieved by tilting the rotor discs forward and backward differentially depending on direction of yaw required. At higher airspeeds, differential rotor control is gradually supplanted by the large aerodynamic rudder on the fin. Ascent and descent are controlled by the collective lever increasing or decreasing pitch of both rotors simultaneously. Large elevators on the tailplane control fuselage attitude and provide reaction to pitching moments from the wing and variation on rotor disc angle. The control system is complex due to the sheer size of the aircraft and the need to cater for aeroelastic deformation of the structure, as well as the very large friction loads of the control rods, levers etc. to keep control forces felt by the pilots to a minimum. The control system is in 3 distinct phases. Phase 1 is direct mechanical control from pilot inputs which is fed into Phase 2. Phase 2 is the intermediate powered control system with low-powered hydraulic boosters transferring commands to the third phase. Phase 3 is the high-powered rapid action control actuators at the main gearboxes operating the swash plates directly. Operational history: construction of the first prototype was completed in 1968. A first flight on June 27, 1967 ended prematurely due to oscillations caused by control problems. One set of main wheels contacted the ground hard, bursting a tire and bending a wheel hub. The cause of the oscillations proved to be a harmonic amplification of vibrations in the cockpit floor feeding back into the control column when a roll demand was input into the cyclic stick. It was widely but erroneously reported in the Western press that the aircraft had been destroyed. The first prototype, given the registration SSS 21142, made its first flight on July 10, 1968 from the Mill factory pad in Pankhi to the Mill OKB test flight facility in Lyubitsy. In February 1969, the first prototype lifted a record 31,030 kg payload to 2,951 m. On August 6, 1969, the V-12 lifted 44,205 kg to a height of 2,255 m, also a world record. The second prototype was also assembled at the Mill experimental production facility in Pankhi but sat in the workshop for a full year awaiting engines, flying for the first time in March 1973 from Pankhi to the flight test facilities in Lyubitsy. Curiously, the second prototype was also registered SSS 21142. The prototype V-12s outperformed their design specifications, setting numerous world records which still stand today, and brought its designers numerous awards such as the prestigious Sikorsky Prize awarded by the American Helicopter Society for outstanding achievements in helicopter technology. The V-12 design was patented in the USA, Great Britain and other countries. Despite all of these achievements, the Soviet Air Force refused to accept the helicopter for state acceptance trials for many reasons, the main one being that the V-12's most important intended mission no longer existed, that is the rapid deployment of strategic ballistic missiles. This also led to a reduction in Antonov An-22 production. In May-June 1971, the first prototype V-12 SSS 21142 made a series of flights over Europe culminating in an appearance at the 29th Paris Air Show at Le Bourget wearing exhibit code H833. All development on the V-12 was stopped in 1974. The first prototype remained at the Mikhail Lentyevic Mill Moscow helicopter plant in Pankhi Tomilino, Lyuboritsky district near Moscow and is still there today at 55°40 €2 to €3 N37°55 €2 56 €3. The second prototype was donated to Munino Air Force Museum 50 km east of Moscow for public display. World records records are certified by the FAR Copyright DAO Copyright Russian or Copyright Ronotique International. The V-12 first prototype has held 8 world records, 4 of which are still current, in the FAIE-1 general class for rotorcraft powered by turbine engines. The aircraft was crewed by, February 22, 1969, pilot, Vasily Kolachenko, crew, L.V. Vlasov, V.V. Jerneljov, V.P. Butchenko, S.G. Rybalko, A.I. Krochkov, August 6, 1969, pilot, Vasily Kolachenko, crew, L.V. Vlasov, V.V. Uravlov. V.P. Batchenkov, S.G. Rybalko, A.I. Krochkov. Variants, V-12, OKB designation of the two prototypes of the proposed Mi-12 production version. Mi-12, designation reserved for the expected production version. Mi-12M, a further proposed refinement of the V-16 with two 15,000 kW Soloviev D30V turbofans driving six-bladed rotors, to transport 20,000 kg over 500 km or 40,000 kg over 200 km. The M12M was cancelled at the mock-up stage when the V-12 development program was cancelled. Specifications, data from Mills heavy lift helicopters, Mi-6, Mi-10, V-12 and Mi-26, Jane's All the World's Aircraft 1975-76, General Characteristics, Crew, 6, Capacity, 196 passengers. Normal 20,000 kg, maximum 40,000 kg. Length, 37 meters, wingspan, 67 m across rotors, height, 12.5 m, empty weight, 69,100 kg, gross weight, 97,000 kg, max takeoff weight, 105,000 kg, freight compartment, 28.15A, 4.4A, 4.4M, power plant, 4A, Soloviev D25EF turboshaft engines, 4,800 kilowatts each, main rotor diameter, 2A, 35 m, main rotor area, 962 m. 25-bladed rotors located transversely, performance, maximum speed, 260 km per hour. Cruising speed, 240 km per hour, range, 500 km, ferry range, 1,000 km with external fuel tanks, service ceiling, 3,500 m, disc loading, 50.5 kg per meter 2 at gross weight, hovering ceiling and ground effect, 600 m, hovering ceiling out of ground effect, 10 m, avionics, April 44 autopilot, VUAP2 experimental autopilot, ROZ1 Lotsia weather and navigational radar. See also, related development, Mi-6, aircraft of comparable role, configuration and era, Mi-26, Yakovlev Yak-60, HOT helicopter. References. Notes Bibliography External links, Mi-12 data and photos at Aviation.ru, about Mi-12 CCCP21142 at avia-dejavu.net, Mi-12 Homer on airliners.net, Mi-12 video in English.